So for instance, okay, so again, just that square root can be written as x to the power of half, and a rational number is a number that can be expressed as the quotient of two integers, right? So what's an example of something that's not a rational number? Just out of curiosity, just to refresh you. It'd be, by definition, something that can't be represented as a fraction. So give me a number that can't be represented as a fraction. Bryce? Pi. Pi is an irrational number, is what we would say. Can you give me another one? Root 2 is another good one. That's good because that's actually the one I was exactly looking for, because we're going to talk about the square roots today, or just like rational exponents. Okay, you can't actually represent the square root of 2 as a fraction. Okay, so those are irrational numbers. Okay, so in general, what we're going to write is x to the power of 1 over n. That n, whatever's in the denominator of the square roots, or sorry, of the rational exponent, goes in the hook portion of the square root, or of the root. Does that make sense? That wasn't explained particularly well. I'm still waking up a little bit. Okay, can you see like the denominator of the rational exponent ends up in the kind of hook portion of the root. Okay, so if it's a square root, that denominator would be 2. If it was a cubed root, it'd be 3, so on and so on, right? So if n is greater than 1, n is a part of the real numbers, okay? So we get x to the power of m over n can be rewritten as x to the 1 over n to the power of m, okay? This looks like a lot of jumble, but it is stuff that you saw yesterday with your power laws. This is just going in the opposite direction. What we would do there would just be, you'd have powers raised to powers, so you would multiply the exponents. Can we see that? That's just kind of going in the opposite direction of the work that we saw yesterday. And then subsequently, the rational exponent can be written like this. That where n in the denominator just gets put into the hook of the square root, or of the root, sorry. Not square root, just stop calling it square root. Okay? And then, all said and done, that's how that can be written. Okay, so we can take something that looks like this, basically is the moral of the story. We're going to go through 4 steps. Okay? And that we can express or evaluate that when it looks like that. Okay, at any of those stages along the way, they're all equal. Okay, they're just trying to communicate the same thing. Okay? So as we work through these examples, and sorry, also where m and n are both integers and the base can't be 0. Okay? All right. Are we okay? All right, let's just try some examples. So I think for your benefit, just try and rewrite these things. Okay? So the denominator of the exponent always goes in the hook portion of the square root, of the root. I gotta stop calling it square root. Okay? So it's, to rewrite this, we could write this. You see what I'm saying? And all I'm doing there, that kind of has come from, not kind of, it has come from this process up top, where I've taken something that looks like this and converted it into something like this, which is maybe a little bit easier to evaluate, right? What's 4 cubed? What is it? 4 squared is 16. What's 16 times 4? Okay, so you get, do we or do we not know the square root of 64? Okay, do I need, Jacob, yet? What's that imply? That's actually maybe something you haven't seen before, but it is, you haven't seen it written like that, but you've definitely used it before. Let's just think about what happened from the 64 line into the 8 line. What happened? Like, how did I get from 64 to 8? Square root. You see what I'm saying? That's why it's called the square root. Now, the reason why I say you've never seen it before is because it's just square root is like, that's probably the most common one, so we just don't write the 2 in the hook. That's maybe why you haven't seen that before. But you definitely have seen what? The cubed root. Okay? So all we're trying to do is communicate where, like, it's just a rational exponent that we take the denominator and put it in the hook portion of the root. That's why we call it a square root versus a cubed root versus the 4th root, 5th root, 6th root, any number of them. Okay? Just square roots and cubed roots are maybe the ones that are most commonly used on your calculator. That's why you see them. But they're all just rational exponents. Okay? Want to try the next one? The next one should be 2 to the power of 4. What's the cubed root of 2 to the power of 4? That's what that's reading as. So I would do, okay, well, 2 to the power of 4 is going to be 16. And I'm looking for the cubed root of 16. So obviously, like, there is a number that you can multiply by itself 3 times to give you 16, but it's not a nice one. And so this would be a question that I would maybe, for sure, expect you to have a calculator for, right? And so we can actually get the number to be 2 point, I got 2.52, but it's okay. Okay, another way to write this, just so we're all clear, like, you can put these into your calculator. Like, what do you do if it's something like, oh, we'll get to it in question D, but just look at the difference between, like, question D and question B. Okay, that's something you haven't seen before, like the 5th root. What's the 5th root? Right, again, you're trying to identify a number that you can multiply by itself 5 times to give you 54. This may be something you haven't really thought of before, right? Okay. What's this, though? Question C. Again, something I think you've seen before. It just looks a little bit different. Also, by the way, you can actually, when you go to evaluate, if I just say evaluate these questions, this is how you would type this into the calculator, which I think we've talked about yesterday. Owen? 9. It's 9. And how do we know it's 9? Because that looks a little bit weird. That's something that you maybe haven't seen before. Is there a way to rewrite that so that we can maybe do this without a calculator? This would be your calculator approach, which is totally acceptable for something that's like to the power of 1/5, like in question D, right? But what's another way to write this? Oh,
cubed root of 27.
Yeah, the 3 goes in the hook, or like the hook portion of the root, which we now call it the cubed root of 27. So again, you're looking for what number times itself 3 times gives you 27. That sounds like, what is it?
9.
Is it 9? 9 is 3. It's 3. Okay. Everyone getting the idea? Okay, just be careful. I think the only thing that trips kids up with this is where the numbers go from the exponent. The denominator of the exponent always goes in the hook portion of the root. Okay, so it's the 4th root, 5th root, 6th root, 7th root, whatever it might be. Okay, so for the next one, can you identify, if I rewrote this or type it in your calculator, this would be the 5th root of 54. So is there a number that I can multiply by itself 5 times to give me 54? What is it, Jacob? 10.8. 10.8? How did we type that in? Okay. This is actually, although you have a calculator, it's actually not as straightforward as you think it is to do it's 2.22, so let's figure out how to get that, because I have a feeling I was a little bit ambiguous in the way that I wrote this question C. That exponent needs to be in brackets. For the reason why. Can we explain why? The reason why is going to come from what your calculator is actually interpreting if you don't put brackets in there. So, and I'm wondering, to Jacob's point, I'm wondering if what's happened here, and Jacob, you can correct me if I'm wrong, for anybody that does this, without the brackets, what do you think your calculator is reading? And I think this is exactly what's happened. Let's think about what your calculator is seeing there. It sees 54 to the exponent 1 divided by 5. So all I'm trying to communicate is that the exponent you should put in brackets. Otherwise, this is what it's going to see. And then I think that's where, Jacob, what answer did you get initially? 10 point something?
Yeah.
9, that's pretty close. 9 point something? Pretty close. Or no, it is 10 point something, yeah. So I think that's exactly what the calculator has seen. You're doing 54 to the exponent of 1. It's doing equals, and then you're taking that answer and dividing it by 5. So you have to put the exponent in brackets in order to get the right answer if you're evaluating with your calculator. Is that okay? Okay. All right, so you should get 2.22 for that. Okay, cubed root of 20. This lesson's a little bit excessive from a work-wise, I guess. Then we happen to know the cubed root of 64 off the top of their head. Robbie says 4. Does that sound right? 4 times 4 is 16. Times 4 again would be 64, I think, right? So again, you could rewrite that as 64 to the exponent of 1/3. Or you could just know that the cubed root of 64 is going to be 4. Okay. Here's where maybe things get a little bit interesting. Okay, and there are some questions in the homework to allude to this. Talking about, and I think maybe we have talked about this a little bit. When I have like an odd exponent, so an odd integer exponent on a negative number, what ends up happening? What's happening right now? Did we listen to the question? Was it just not a good question? Not a good question? Something like -2 cubed. You're gonna get a negative because that like idea of repeated multiplication says I get -2 times -2 times -2. There's an odd number of negatives there, right? And so you get, you get an odd number of negatives, and so your answer remains negative. But if it's to a positive exponent, like to the power of 2 or 4 or 6, again, that repeated multiplication says there's going to be an even number of negatives, and subsequently your answer is going to come out to be positive. Does that make sense? So this kind of transcends into the rational exponents as well, right? Like the cubed root, you can take the cubed root of -8 actually. What number, and remember it's very important for you to ask yourself what is actually happening here. When I ask you what the cubed root of any number is, you're asking what number can I multiply by itself, in this case 3 times, to give me the answer that's underneath the cubed root sign, or the root, the radical. So, what number can you multiply by itself 3 times to get you -8? Sophie?
-2.
-2. So you can take the cubed root of a negative number. What can you not do? You can't square root a negative number. nor can you take the fourth root of a negative number, because that's an even, what's the word I'm looking for, radical? Even radical? Does that make sense? That might not be the math formality term, but an even radical, if you will. Okay, so this is actually -2. Okay, and then we're going to mix in the negative exponents as well from yesterday. What's the negative exponent mean? Yeah, flip. So you take, this is the same thing as 1 over 64 to the 4/3. Okay, and now what? This is a little bit different because the exponent looks a little bit different. It's not just 1 over something anymore, is it? It's 4 over 3. This is where you're going to start to get a little bit confused. But just always remember, whatever number is in the denominator of the rational exponent goes where? In the hook. Okay, it's an easy way to remember it. Whatever's in the bottom, just grab and put to the hook, right? So I'm going to get 1 over the cubed root of 64 to the power of 4. Oh boy. So we should get something like 1 over 256.
Would it be negative as well?
For H?
Yeah, for H.
Where'd the negative come from, RJ? Or where do you think the negative come from?
It's there in the question.
Yeah, the negative is in the exponent, which is what turned this into that.
Oh, okay.
Yeah, so that, just careful. Like the negative in the exponent is different than a negative on the base or the on the coefficient. Okay, negative exponents mean we make whatever you've got go to the opposite numerator or denominator. Okay, maybe. I think maybe actually, just from a formality standpoint, we'll put that 4 on the outside. I think it might have to be on the outside. Okay, question I. What's that? That actually, like that being an example of a question that I could expect you to do without a calculator. So again, we're going to apply a power law from yesterday. It says, the power law yesterday said, if I have powers raised to powers, you're going to multiply. As well as, like, there's a bit of a quotient law in there as well. That exponent needs to go to the numerator and the denominator. So let's just look at what that does. I get 9 to the 1/2 over 25 to the 1/2. Okay, we've discussed already a number of times today. What does anything to the power of 1/2 mean? It's the square roots. So what's the square root of 9 and the square root of 25?
3 and
3 and 5. So your answer here is going to be 3/5. Okay, so this test here is going to be just as much, because we are going to have applications in this unit. So you have the calculator. Like this unit, I think, is maybe a little bit of it's a nice sigh of relief from what we've been doing in the last month and a half. It's pretty short. Okay, you're gonna have a calculator. There's definitely some just direct evaluate. Can you use your calculator questions on this test? Right. So I take advantage of questions like this. Because ultimately, we're going to do work with these rational exponents in a word problem setting. Okay, that's what's coming, maybe like lesson 6 or 7, whatever it is. Okay. So you have to be able to type this into your calculator. This is an important skill. Like it does require a little bit of a different, from the standpoint of making sure you've got brackets around your exponent. That makes a difference now, as we saw already. Okay, so the evaluation and use of your calculator is actually a skill in itself for questions with this, like this. Okay. What about this? 65 to the negative 2/3. This can be rewritten as 1 over 65 to the positive 2/3 now, which subsequently turns into 1 over the cubed root of 65 squared. Just stare at that. It's the same thing over and over again. Just stare at that. Make sure you're good with where those components from the rational exponent went. It's the same thing over and over again. Okay? There's actually no way for me to really trick you with these questions if you know just the rules, right? Where the components from the rational exponent go. It just turns into something you type in your calculator. Say we get a number for this. I would advise you getting a scientific calculator. If you don't have one, I think Mr. Poling bought a bunch. I think we might have 100 calculators in the math office that you can get for like 10 or 15 bucks if you need one. Okay, that just saves you getting out. Just bring 10, 15 bucks to school and we can get you one if you need one. Okay, and it's yours. They're those black and green ones that some of you have seen around the school over the last couple of years. Casios or something like that. Okay. Okay. Maybe we get a number for that when they type that in. It's funny, eh? It's like we say, okay, you can have a calculator and you just type this into your calculator. It's actually a bit of a skill set to get these answers. A little bit weird, eh? So do you want to dive into how that came to be? All right. So I don't have it on my page, so let's just talk about it. What is the cubed root of 65? Somebody type that in their calculator. You can do cubed root 65. Here, I'll write the order by which you do this in, I think. Cubed root 65 equals an answer 1. And then you're going to take answer 1.
It says syntax error.
Okay, we just got to figure out why it's doing that. Answer 2. And then 1 divided by answer 2.
Oh, wait.
Hey? What's the matter? Oh. Are we okay? Try that again. Try it. If we still get a syntax error, we can deal with it. But okay, sorry, I'll move it up too. I know there's no reason for that. Okay, that's how I would do that if I was typing in my calculator. I wouldn't try and do this all in one step because I don't know, just susceptible to error or typing something in wrong. So I take the cubed root of 65. I'd hit equals. It would give me a number. The nice thing about the scientific calculators is it saves that number, your most recent answer, by which you can now take. There's an actual answer button on most calculators, A and S, that goes answer squared. You can hit equals. That'll give you a new answer, 2. And then you can go 1 divided by answer again. That should give you the answer that we're looking for. Is that okay? You should get, I'm not, like 0.06. Does that sound right? Did anybody else reproduce that?
Yeah.
Okay, so that seems right. So if it's, we'll do a little bit of it when we start to sit down and do some work. We'll do some individual like calculator skill stuff. Okay. Okay. Shy away from. Obviously, you can't have your phone in a test, so that's out the window. I'm not letting you have your phone. Okay, so you better get something. Okay. Okay. Oh, question K. What am I going to do here? I would apply some power laws here. This is a to the 1 minus 1/2, b squared minus 1/3. So we get a to the 1/2 multiplied by b. What's 2 take away 1/3? Robbie? 5/3, yeah? Are we okay with that? So I'd create a common denominator by multiplying by 3 over 3. I'd get 6/3 take away 1/3 would be 5/3. And so maybe a final way to write this just so that you've seen it. I'm kind of okay with that. That's simplified. I'm okay. Another way that would be acceptable too would have square root of a multiplied by the cubed root of b to the power of all raised to the power of 5, I guess. Okay, square root is much like a 1 in front of a variable. You don't need to write it. It's just implied that if there's no number inside the hook portion of that root, that it's a square root. Okay. Kieran?
Would the root and the exponent cancel out in any way, or?
The root and the exponent.
Because it's being square rooted and then it's to the exponent of something else.
Which one are you referencing?
The 5. Or the b, sorry. Would it be b squared?
No, because it's like the rational exponent is much different than, it's not b squared. Because it's the cubed root of whatever b is to the power of 5. That's how that's read. Okay, so whatever your answer is to the power of 5. It's not, which would not be the same thing as just squaring whatever b is. Okay. Okay. Everybody okay? Let's give this a go. This one's going to be a little bit messier. Okay. I'm going to get here. We're going to distribute the exponent to everything on the inside of the bracket. So I get 8 to the 2/3, x to the 2/3, multiplied against 27 to the negative 1/3, x to the negative 1/3.
How'd you get 8 to the 2/3 minus x?
That's a sorry, a little dot. Little dots. I should put brackets around them, but do you prefer brackets? You can use brackets if you want. That's a bit better, I think. That's a good call. Maybe avoid using the dots because they do turn into looking like minus signs, I guess. That's fair. Fair enough. Okay. You could also just write nothing, and that's implied that it's multiplied together, but you can put it in brackets. That's good too. Okay. Do we know what 8 to the 2/3 is? So if I rewrote this, it's going to be the cubed root of 8 squared multiplied by x to the 2/3. And then all that is going to be divided, all that's going to be divided by 27 to the 1/3, x to the 1/3. I'll let everybody get caught up. Make sure you're okay with that. Jacob?
Why can't you rewrite 27 1/3 as like 3 root 27?
You can. I just didn't want to do that in that step. Is everyone okay if I do that? I just didn't want to do that because I took that negative exponent and turned it into positive first, just so everybody didn't get completely lost. How something from to the negative 1/3 turned into a cubed root. Okay, we could actually take this now. Oops. We can take, you can take this and rewrite it as, if I erased it, the exponent, it's the cubed root of 27 multiplied against the cubed root of x. But I'm gonna leave the cubed root of x, like I'm gonna leave x to the power 1/3 for a sec for you to see something. Is everyone okay how we got there? So now you can maybe do a little bit of evaluation, right? Like I know the cubed root of 27 and the cubed root of 64 is what's sitting there in the numerator. Everybody see that? So I get the cubed root of 64 over 3, because the cubed root of 27 is 3. And then I'm going to multiply that by, I have a power law here. I have x, you can, it's kind of like canceling, but that's why we show you the power laws, because how do you cancel 1/3 out of 2/3? You know what I mean? So use the power law. It's going to be multiplied by x to the 2/3 minus 1/3. The cubed root of 64 is what? What number times itself gives me 64? What number times itself 3 times gives me 64? Is the question. 4. Okay. So I get 4 over 3 multiplied by x to the what? 1/3. Which could be finally rewritten as 4x to the 1/3 over 3.